This is your part 1 video for 4-2 graphing rational functions. And so our essential question basically mirrors what the title is. How can you graph a rational function? We're going to look at a couple of different methods here. We are going to be incorporating the graphing calculator to help give us some guidance on how to graph some things. This exploring reason, you may or may not be assigned that to do in class, but I am going to be skipping over that for now. So first, for example 1, it says rewrite the function below using long division. How is the quotient related to the reciprocal function? And then sketch the graph. So doing your long division on this, the 4x is going to go on the inside. The x minus 3 goes into the outside. X goes into 4x 4 times. That's going to give me a 4x minus 12. And I am subtracting. Remember, there's an understood 0 here. So that's going to give me 12 as a remainder. And so I can rewrite this instead of 4x over x minus 3. This is 4 plus 12 over x minus 3. So you can see if we were looking at what we were doing in the last section, this is 12 over x minus 3 plus 4, where 4 is going to be the horizontal asymptote, and 3 is going to be the vertical asymptote. So we are taking the graph of the 1 over x, the graph of the reciprocal function, we are shifting it up 4 to the right 3, and then it is going to be stretched vertically by 12. Before we had a 1 on top, this one has a 12 on top, so instead of zeros being my asymptotes, I do have an asymptote up here at 4. I have an asymptote at 3. And then I'm going to be stretching everything by 12. So you can still go through and plug in some numbers. I'm going to make sure I plug in numbers on both sides of 3, and I can simplify to get some points to graph. If I plug in, for example, 1, 1 minus 3 is negative 2. 12 divided by negative 2 is going to give me negative 6. And negative 6 plus 4 is negative 2. So 1, negative 2 is going to be down here. Notice this one does look quite a bit different than what we had before. If I plug in 0, I'm actually going to get back 0, because 0 minus 3 is negative 3. 12 divided by negative 3 is negative 4. And then plus 4 is 0. Negative 1. I plug in negative 1. Negative 1 minus 3 is negative 4. 12 divided by negative 4 is negative 3. So that's actually going to give me 1. So this is going to curve out kind of like this. And I am taking some liberties there with that. It's not going to look quite the same way. And then if I go greater, these are going to get pretty high pretty fast. If I do 5, 5 minus 3 is 2. 12 divided by 2 is 6. 6 plus 4 is 10. So 5 would put me up at 10. 6, I would get 3 and 4. 6 would put me at 8. 7 would put me at 7. And then 8 is going to give me a decimal there. 9 would actually put me up at 6. So that would be out there. So this part is going to look something like that. So you can use the idea of the reciprocal function to kind of connect with this. That's where the long division comes in. You could also do synthetic division on this if you wanted to. You would get the same answer. You just have to make sure that you write it in the correct way. So this is really our start of rational functions. Just as a rational number is a number that can be expressed as the ratio of 2 integers, a rational expression can be expressed as the ratio of 2 polynomials, such that your q of x, whatever's on the bottom, is not equal to 0. Your rational function is defined by any rational expression where your r of x is equal to u p of x over q of x. And again, q of x cannot equal 0. So the function that we just looked at, 4x over x minus 3, that is a rational function. So we're dealing with a lot of basically polynomials within fractions in this chapter. So example 2, find the asymptotes. This is part A. How do you find the vertical and horizontal asymptotes? Although this part A only asks us to find the vertical asymptotes. Your vertical asymptote is going to occur when your denominator is equal to 0. So for most of these types of questions, if you don't have something that is a reciprocal function like we had in the previous one where we could put it into that x minus h format, although we actually are still technically using that, it's just that you might have multiple h's. You want to take whatever denominator you have, in this case, x squared plus 7x plus 12, I'm going to factor it, and I'm going to set it equal to 0. Well, my a value in the bottom is equal to 1, so I can factor this into x and x. Now I'm looking for factors of 12 that add to 7. That's going to be 3 and 4. So if I solve those, I get x equals negative 3 and x equals negative 4, which means my vertical asymptotes for this question are at x equals negative 3 and x equals negative 4. There are 2 of them. It is possible to have multiple vertical asymptotes. I'm going to pull up the calculator just so you guys can see this. This might look a little bit different than what you've seen in class before. I had to get a new program, so really pay attention to the calculator on the left for the key presses, and then the screen on the very right. The middle is a little bit slow to load. So I am going to graph this. I do need to put the top and the bottom in parentheses. So I have 3x minus 2 divided by, on the bottom, x squared plus 7x plus 12. And you can see if we take a look at that graph, you can see there, it actually looks like there's a big gap in between my negative 3 and negative 4. But if I look at the table of this, I'm going to go up here. So you can see negative 3 gives an error, negative 4 gives an error. There is actually values in between negative 3 and negative 4 that I could plug in, and I'm actually going to zoom in on that so you guys can see that a little bit better. But negative 3 and negative 4, they both give me errors. They're both asymptotes. Now, sometimes you'll have values that give you errors that are not asymptotes. They're merely discontinuities, so they're like holes that you can fill in, and that's going to be something that we look at more in 4-3. So I'm going to adjust this window a little bit because I want to look between negative 5 and say negative 1. And it looks like whatever's going on is going to be down in the negative y, so I want my y minimum to go down lower. So let's go from 100 to 10 and take a look at that. It looks like it's still not far enough. So let's try this again. Let's just zoom out and see if we can get a better picture of what's going on. So there's me zooming out. There's my asymptote. Still don't have a picture of what's going on in the middle. Let's zoom out again. Zoom out even further. There we go. So it was up above. You see there's this little piece of the graph in between negative 3 and negative 4. It's probably like a very, very narrow quadratic looking thing. So there are you could plug in values in between negative 4 and negative 3. It's just that at negative 4 and at negative 3, there are asymptotes there. Now part B asks about horizontal asymptotes. For a horizontal asymptote, you need to decide which case you have. There are 3 different cases to determine what your asymptote is going to be. Case 1. Case 1 is where the degree of the numerator is less than the degree of the denominator. So that means whatever the highest x power is on top, it's still not as high as whatever the x power is on the bottom. For example, here you can see there's an x on the top, in this g of x that's given, an x squared on the bottom. When that happens, there is always an asymptote at x equals 0. Case 2, the degree of the numerator is greater than the degree of the denominator. For this one, we have an x squared on top and an x in the bottom. This has no horizontal asymptote. So if the top degree is bigger than the bottom, then there is no possible asymptote. For case 3, let me move this a little bit so you can actually see what's there. Case 3, the degree of the numerator and the denominator are the same. If that happens, I know it says use long division, but you can basically just divide the leading term of the top by the leading term of the bottom. So in this case, the 2x squared on the top by the x squared on the bottom, you get 2, which means in case 3 down here in the example that's given, this k of x, y equals 2 is going to be your horizontal asymptote. So in what's given here, let's try this again. We have 3x on the top. I have an x squared on the bottom. My top exponent is smaller than my bottom exponent, which means this is a case 1 situation. And because it's case 1, my horizontal asymptote has to be at y equals 0. That's always going to be the case if the top exponent is smaller than the bottom. This case 1, 2, and 3, it is in your textbook. It might be a good idea to go back and copy these down with some shorthand so you can reference that later, because this is something you will be expected to know on a test or quiz. That's going to conclude our part 1 video. I didn't want to overload this too much. Part 2 will deal further with finding vertical and horizontal asymptotes, looking at doing some more graphing, and also tying in a real-world example. So go back, rewatch this video. There should be Khan Academy videos you can also look at if you need some extra help with this topic, and reach out to me if you have any questions at all.